Greetings, fellow mechas. Today we'll be looking at a cost minimization problem. The problem. The production function is FLM equal 2L to the 1 half times M to the 1 half, where L is the number of units of labor and M is the number of machines. If the amount of both factors can be varied, and if the cost of labor is $64 per unit and the cost of using machines is $1 per machine, calculate the cost minimizing combination of L and M that are capable of producing 160 units of output and the total cost of producing 160 units of output. Now pause this video, take a few minutes and solve this problem. Welcome back. Hopefully you're able to solve this problem. Now let's solve it together. So to start off, let's write out our cost function. So what are we minimizing? Well, we are minimizing on costs, which is going to be equal to W1, so the wage or the price we pay per X1 plus the wage or the price we pay for X2. So W1 we would denote as, let's do this. W1 is going to be the wage or the price per labor. So let's do $64 for W1. And W2 is going to be the price or the cost of using the machine, which is going to be $1. And X1 and X2 is unknown. That is what that is unknown. So now, what is our minimizing cost function subject to? Well, we are constrained to our production function. What can we actually produce? So subject to FLM, which is going to be equal to 2L to the 1 half times M to the 1 half, which is going to be equal to the cost of producing 160 units, because we looking, so 160. So that is our first equation. Now we're going to set up the Lagrangian method to solve this equation. So what we are minimizing, so let's do this. We're going to be minimizing with respects to L and M, or labor and the cost of the machine. So L is going to be equal to W1 X1 plus W2 X2 minus lambda, and then our production function, which is going to be 2L times M 1 half to M to the 1 half minus 160. Now from here, now we got the Lagrangian method set up for this problem. We're now going to take our first order condition. So first order conditions. Now the first one we're going to take, so this could be a first number 1. Let's take the partial derivative with respect to L. So let's do this first. This would give us W1 minus lambda times L to the negative 1/2 times M to the 1/2, which is going to be equal to 0. And then let's, the second partial derivative, let's take this with respect to M. This will give us W2 minus lambda times L to the 1/2 times M to the negative 1/2. It's going to be equal to 0. And finally, let's take the partial derivative with respect to lambda. So lambda, this will give us negative 2L to the 1/2 times M to the 1/2 minus 160 is going to be equal to 0. Now from here, we'll need to solve for either M or L. So to do that, we can just take number 1, our first order condition that we solved for, and divide it by our second first order condition. So this is basically 1 divided by 2, our first and second, which is going to give us W1 over W2. And then we take the minus lambda L and move it to the right hand side. And if you do that, you'll find out that we get M over lambda over L. So if we solve for M, this will give us M is equal to W1 times L over W2. And now that we found our M, we can plug M into our production function and solve for L. So let's solve for L now with regards to our production function. So we have 2L to the 1/2 times M, which we just found was W1 times L over W2 to the 1/2. Now this is going to be, now let's do 2L, because if you just distribute the 1/2, this comes L to the 1/2, and use your exponent rules, 1/2 plus 1/2 is 1 times W1 over W2 to the 1/2, and this is going to be equal to 160 as the question stated. That capable of producing 160 units of output, so this is going to be equal to 160, and then we can move this over to the right hand side by taking the reciprocal essentially. So, and we can also divide by 2, so we can solve for L. So if we do this all in one step, we'll see that it's L is going to be equal to W2 over W1 to the 1/2 times 160, and then the whole thing's going to be divided by 2. And this gives us our equation for solving for L, how many units of L we're going to produce or use, how much labor, number of units of labor we're going to use as a cost minimizer. And to find the same thing for M now, well, we plug in L back into M. So remember what our M was up here. So I write it down again. M was equal to W1 times L over W2. So this is going to be one of our equations we're going to use to find how many units of labor we want as a cost minimizer. And then now we can just plug in, so M is going to be equal to W1 times L, which is W2 over W1, so 1/2 times 160 over 2. Divide this by W2. And how we solve this? Well, we times this by W2, both sides cancel, so M times W2 is equal to W1 times W2 over W1, so 1/2 times 160 over 2. And then we can divide by W2 again. And you're going to see that we get M is going to be equal to W1, because W1 over W2 to the 1/2. And how does this happen? Well, basically this is negative plus a positive 1/2 for W1, because it's in the denominator. If you use your exponent rules, you see that is, if you bring it up, 1 plus a negative 1/2 is 1/2 for W1, and then if you divide this by W2, well then it'd be W2 1/2 minus W2 to the first, and then you get negative 1/2, so then you bring this to the denominator. This is how you get the W1 over W2 to the 1/2, and then 160 remains 160, and then the whole thing is still just divided by 2. So this gives us M. So now we have our equations for both M and L as a cost minimizer. So now we just plug in our W1, which was equal to the cost of labor, which is 64, and W2, which was equal to a cost per machine, which is 1. And if you plug them both into if you both plug in W1 and W2 into L and M, you find that L is going to be equal to 10, M is going to be equal to 640. So don't forget, this is plug in W1 and W2 into M, gives you 640, and plug in W1 and W2 into L will give you 10. So as a cost minimizer for this production function, producing 160 units of output, you want 10 units of labor and 640 machines. That's what it's saying essentially. And the total cost, so as a cost minimizer, this total cost for producing 160 units of output with 10 units of labor and 640 machines, this total cost is going to cost 640 times 1 plus 10 times 64. So this gives us an answer of $1,280. So the cost minimizer of this production function, you would like 10 units of labor, 640 machines, and it would cost you as a cost minimizer $1,280. Hopefully this video helped. If it did, please consider subscribing and liking this video.